Okay, today we'll be talking about equations of rotational kinematics. Recall there are equations of kinematics for constant acceleration. And here they are. They should all look familiar to you. And here's the terms that were involved with linear kinematic equations. And these were constant acceleration equations. Yeah, displacement was measured in x, acceleration was a, velocities were v, and time was t. All right, when we talk about angular, it's really nothing new. Same idea and really the same equations. For example, velocity final is equal to velocity initial plus at, and there's the angular equivalent. It looks exactly the same. We're just using angular terms. Here's another equation. There's its angular equivalent. Third equation, and its angular equivalent. Fourth equation, and its angular equivalent. So you can see there's really nothing new. We're just using different terms. Instead of using linear terms, we're using angular terms. Okay, so let's look at it a little closer. What is this equation using? Well, it's using angular terms, and alpha is the angular acceleration, omega is the angular velocity, theta is the angular displacement, and time, once again, is still time. And here's the other two equations. Okay. So, really they're the same equations, but we're just replacing linear terms with angular terms. You know, displacement x with theta, velocities with omegas, alpha, accelerations with alpha, and still using time with time. So how do we solve problems like this? Well, it's really the same. You're going to make a drawing. You decide which way is positive. The convention is that counterclockwise is positive. You're going to write down any of the variables that we know, like any of the 5 variables. And you're going to hopefully have at least 3 of the 5 kinematic variables. You're going to select the appropriate equation to solve for the unknown. And remember that the final of one part of the problem could be the initial part of the next. And sometimes there could be possibly 2 answers to kinematic problems if you're solving for like squares and stuff like that. All right, let's try one. So we got a blender that's rotating, and we know the displacement is positive 44 radians. Now positive 44 radians would mean that it is going in the counterclockwise direction. The angular acceleration is 1,740 radians per second squared. We know that it started with an initial angular speed of 375 radians per second. And we want to know what the final angular speed is. And we're not given time. So we have to use an equation that doesn't have time, but has these 3 variables in it and this variable that we're looking for. And that equation would simply be this, where the final angular speed squared is equal to the initial angular speed squared plus 2 times the angular acceleration times the displacement. And we can arrange this equation and solve for omega. And we can put the terms in, as you can see, and solve for the answer. It's really important to note, that all these variables have to be in radians. Displacement needs to be in radians. Omega, angular speed, needs to be in radians per second, and angular acceleration needs to be in radians per second squared. You can't use like degrees or revolutions and get the correct answers utilizing these equations.